All right. Good evening, everybody. Welcome to day 26 of Math 133. We are near the end. I can see the end. Day 30. It's our last day. Um, so today we're going to be covering the cumulative review worksheet number 7, and that's on page 595. And this cumulative review is going to cover chapters 1 through 10. So we're not doing all of the cumulative reviews. Cumulative review number 8 we're not going to do. And that covers chapters 1 through 11. And chapters 1 through 11, that's all the chapters that will be on the final. So cumulative review number 11, number 8, it's probably a good one to study off of if you need more additional practice. Okay. Um, so today, as I said, we're going to cover the cumulative review on page 595. Um, Thursday is Thanksgiving, so there's no class. So there's no discussion board. If you miss today's Zoom call, that's okay. But make sure you come next week, okay? Um, so for those of you who are behind on your work, make sure you get things turned in. Remember that if you haven't turned anything in for 2 weeks, you could drop from the class. And at this point, I'd hate for you to have done all this work just to get dropped from the class. So make sure you get your stuff taken care of. Make sure you get caught up. The last day to turn anything in is going to be Friday, December 12th by midnight. Okay. So anything turned in after that, it's not going to be accepted. So, um, okay. So today, cumulative review number 7. Now, if you click on the cumulative review in Canvas here, there's a link. And if you click on that link, it'll bring you to this huge data set list of all the data sets for all the different worksheets. So way down at the bottom is the one for cumulative review number 7. There's 2 links here. One of them will take you to the Google Sheet that we'll need for question number 1. The other one for StatCrunch doesn't look like it's working. Yeah, so that one's not working. So that's okay. We'll be all right. So but at the very least, you'll need the Google Sheet one, okay? Because that's going to open this, and we're going to need this for the first question, okay? Okay, so page 595. Okay. Um, so we've seen these kind of frequency distributions before. So you'll fill in your midpoints, relative frequencies, all of that stuff, okay? I prefer if you write it on the paper and turn in the paper into Canvas as opposed to, I mean, I guess it's okay if you want to fill in the numbers here on Google Sheet and share the link with me. Um, I'll just have to open 2 different files, which is fine. But so once you get all the numbers filled in, let's see. So question H down here, find the following for this distribution, find the mean and the standard deviation. We had 3 methods on page 254 on how to calculate standard deviation. Okay, so page 254 in our exam notes packet. So we don't have a single column of data. We have frequencies and midpoints. We have a whole bunch of different columns. So it's not method 1. Method 2 is if you have a frequency distribution. So you have a data table with whole numbers for your frequencies, and all these frequencies, these are whole numbers. So this is method 2 on page 254, okay? All right. On the next page, page 596, the following table presents the number of screenings for breast cancer and cervical cancer by different race, ethnicity for a sample of patients in the US. So a patient is randomly selected. Find the probability of selecting someone who A is screened for cervical cancer. So probability is wanted over your total, okay? You might have seen it, and sometimes we write it as X over N, right? So X in this case is cervical cancer is this one, 10,487. And my total, my sample size altogether is 17,176. Okay. So whatever that is a decimal. Okay. All right. So in statistics, when we see the word or, okay, we have to be careful with that depending on whether it's disjoint or not. So when we have E or F, there's two different ways we could do it. First, you can just add the probabilities together if there's no overlap. So in this case, Asian or Hispanic, you can't be both Asian and Hispanic. So there's no overlap here. So you can just, so those are disjoint. So you just add the two probabilities together. But if there is an overlap, like this one, is Hispanic or is screened for cervical cancer, both of those can be true. You can be Hispanic and also get screened for cervical cancer. You have to use the general formula, which for or, you add the two probabilities together and then you subtract the and part. You subtract where both are true, the overlap. Okay. All right. Would any of these events be considered unusual? So these are all going to be probabilities. So we consider it unusual if probability is less than 0.05, 5%, okay? If we were looking at z-scores, these are not z-scores, but if you had z-scores, we would want to check and see if it's greater than 2 or less than -2 for it to be unusual, okay? All right. For each of the following, circle true or false as appropriate. False, explain why. So, first one, sampling bias arises from the fact that all samples are slightly different and no sample perfectly mirrors the population. So, what do you guys think for this one? True or false? Sampling bias arises from the fact that samples are slightly different and no sample perfectly mirrors the population.
True.
True? Okay. So, this one's tricky. So, sample bias is where you select your sample and it's not random. And when you do that, it doesn't mirror it, it doesn't represent the population. I would agree with that. Um, so this one's false. It's sample error is what it's describing here. Sample error is saying basically if you have a random sample, every sample you select is going to be a little bit different. And so no sample is perfectly mirroring the population, but they closely represent the population. How close? Well, that's what we've been talking about with like the confidence intervals is how far off it could be. So yeah, that one was tricky. Okay, let's try part B. For medical screening tests of communicable diseases like COVID, in general, type 1 errors are the equivalent of false negative test results. I always get these confused. What's type 1? What's type 2? Um, so what do you guys think in this case?
That's false.
That is false. Yeah. Type 1 is false positive. Type 2 is false negative. Yeah, I always get those confused. So I always have to write it down. So this would be good to write on your, 8.5 by 11 piece of paper just to make sure you understand. So, okay. A researcher carried out a hypothesis test using a two-tailed alternative hypothesis. Which of the following test statistics is associated with the smallest p-value? So on our normal curve, so right here is 0. And if you have a z-value that's very close to the 0, like 0.1, you're going to shade a lot of the curve, okay? And it's two-tailed, so you're going to be shading both sides. So you're going to shade a ton of this, and so you have a giant p-value. On the other hand, if your Z value is way out here at like 3 and -3, you're going to shade just a tiny little piece for your p-value, okay? So a number that's really far away from 0, like 3 or -3, is going to be a small p. We're looking for which one is associated with the smallest p-value. So which of these, if you ignore the negative, which one is bigger? Which one of these is the biggest?
3.12.
3.12. Thank you,
Yeah.
Nina. Yep, you got it. So 3.12 is going to, and -3.12, those are going to be really far away from 0. And so you're going to have very small bit of your curve gets shaded. So those will have a small p-value. On the other hand, a researcher carried out a hypothesis test using a two-tailed alternative hypothesis, which of the following largest p-value? So which of these is closest to 0? Yep, you got it. Thank you, Mark. So 0.19 is going to be really you're almost going to be shading the whole thing. It's going to be like 95, maybe 90%. So it's gonna be a huge p-value. All right. Quality control manager believes that the average calories per 5-ounce serving of vanilla yogurt is less than 175 calories. They gather a random sample of vanilla yogurts, and then so these are all their samples, and this is how many calories are in each of the yogurts. Fill out the following table. So we need the mean, the standard deviation, and how many numbers there are in this sample. So in this case, they didn't give us the mean. So what we're going to do is we can do that in StatCrunch, page 254. In this case, we have the raw data. So this is method 1, okay? Method 1, we do summary stats, columns, and then we select which things we want. In this case, we want the mean, the standard deviation. Now, the problem is that that link for StatCrunch was not working for me. So that's okay. So we're not going to do it that way. Let's just, so we'll just open a normal StatCrunch and we're just going to fill this in, okay? So this will be our calories, and I'm just going to fill, there's not that many numbers, so I'm just going to put them in by hand. 220, 230. So that didn't take that long. So I've got 14 numbers. Let me just check and make sure I got them all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, I got everything. Okay, so yeah, that didn't take that long. So now that we've got that, let's find our mean and our standard deviation. So we go to stat, summary stats, columns. And we'll select calories. And I need the mean and the standard deviation. Now, do I want the regular standard deviation or the unadjusted one? This is a sample, so I just want the regular standard deviation. So my mean is 157.857. My standard deviation is 44.752. And my n is 14. I already counted how many numbers it was. It was 14, so okay. All right, no big deal. Verify the requirements to conduct a hypothesis test are valid. So we need to check that it's random, independent, and normal. Okay. Um, Use a 5% significant test to test the manager's claim. So there's six steps here. So the null hypothesis. Um, now, are we measuring a mean or a proportion here? What do you guys think?
Mean.
Yeah, we're looking at a mean. We're looking at what's the average calories in yogurt. Okay, so because this person, whoever this is, they gotta put this on the nutrition label, right? So does every single yogurt have exactly the same number of calories? No, they don't. There's a range, and so the number that they put on there, they need to make sure that it's as accurate as they can. So they're going to put what the average is. Um, so for all of these null hypotheses, we're looking at mu equals. They want to say that it's less than 175. And our alternative hypothesis is mu is less than 175. Okay. So we'll come back and we'll fill in the rest there. Okay. All right, page 598, number 7. In 2022, 25% of US adults said they would buy an electric vehicle for their next purchase. Researcher at Ford believes the percentage is higher now. So it's been 3 years, now it's 2025. They think that that number has gone up. So they gather a random sample and they find that 29% of them would buy an electric vehicle. So I want to pause here and point out, okay, in 2022, the number was this. And then they did their sample today and they got this number. So why can't we just stop here and say, yes, the percent has gone up? Why do we have to do all of this hypothesis testing stuff? So the reason is because you didn't measure the whole population. You didn't measure every single person, every single US adult. So since you did a random sample of 1,000 people, there's a chance that you just happened to select a bunch of people who are very environmentally friendly conscious, okay? Because it's a random sample, okay? And even if it's not biased, I mean, it still could have, be higher or lower depending on uh, how the randomness works out, okay? Um, so you can't just take your sample and say, okay, sample is 29%, that's higher than 25, so the number's gone up, okay? Because what if we had done a different random sample and it came out that that new sample was at 24%? That's lower than what it used to be, okay? So that's why we have to do this hypothesis testing. You can't just base your conclusion on that sample, okay? Now, if you do this hypothesis testing, what that does is it shows you if with a 95% confidence, because we're using a 5% level of significance, that any sample that you take, or at least 95% of the samples that you take, would have been higher. Okay. In that case, you can say, yeah, it doesn't matter that I did a random sample. It doesn't matter that it's random. Anything I would have selected, I still would have gotten a percent that's higher. And so at that point, you can say, yes, I'm pretty confident. I'm almost for sure confident that the true proportion is higher than it used to be. Okay. So that's why we do this confidence testing. So imagine if it wasn't 29%. Imagine if we'd done this and our sample was at 25.1. You can't just look at this and say, okay, well, back in 2022, it was 25%. Now it's 25.1%. That means it's gone up. That's 25.1 is so close that there's a chance that you just, the randomness threw you off. It's kind of like if you roll a dice. If you roll two dice, what's the average? The average of two dice is 7, okay? But you might roll higher, you might roll a 12, you might roll lower, you might get a 2, okay? There's a range of values you can get, okay? So anyway, that's why we do this hypothesis testing. So all that said, okay, so our N in this case was how many people we sampled. Our p-value is 29%. Somebody calculate my Q for me, please. Q hat.
0.71.
71, thank you. Lastly for X, so P hat is X over N. So that means that X equals N times P hat. Okay, so if you multiply those two together, that'll get you that. So let's do 1254 times 0.2. So 363.66, but X is always a whole number. It's the number of people that said that they would buy EV. So we're always going to round that, okay, to the nearest whole number. You're going to round it up or down. You just round it normal, okay? Yeah. So P hat could be a decimal. N and X can never be decimals, okay? Because you can't sample, you know, 1,000.6 people, and you can't have 363.6 people agree with the statement. So, all right, what are the researchers' hypotheses? So, null hypothesis, alternative hypothesis. So, in this case, we're looking at a proportion. So, where I was doing P equals, so it's not 29. 29 is our P hat. We're comparing, this researcher thinks it's gone up. It used to be 25, now they think it's gone up. So the null hypothesis is that it's equal 25%, or let's put that as a decimal, 0.25, okay? So the researcher is hoping that the alternative hypothesis is correct, and that's usually the case, okay? You are always hoping that the alternative hypothesis is correct. And they think that it's gone up. So that means they think it's increased. Okay. All right. Verify the conditions are met for central limit theorem. And I need to make sure it's normal. Okay. All right. I think that's, this is all on page 262 for proportions. And then last page, this was all on page 263 for means. I think that's all the hints for tonight. Let's go back and let's do some math, okay?